Hello Internet, my name is Oliver and today we're going to be doing another sort of tutorial. I want to just kind of do a little bit of a fun, graphical JavaScript or JavaScript based recursion illusion. And what we're going to be building today is something along the lines of this. So this is a simple sketch which effectively the rectangles expand out and it kind of creates this cool little recursion illusion, and we can use anything with this. We could change the rotations, we could change the color, we could do a lot of stuff, and it's also got some elements of like memory management, so so when the square goes off screen it's not being generated anymore. So we're going to be building this today. This should probably take 10-15 minutes. Hopefully this hopefully shouldn't take too long. But before we begin, in terms of how you want to go about programming this, there are two ways you can do it. You can either get the P5.js library from the website and you could just download it and then manually edit the JavaScript, or you can just type in P5 web editor and go to this website and you can just start coding P5.js right away. But for the purposes of this tutorial, what we're actually going to do is that we are actually just going to use my code editor of choice, brackets. And as we see here, we've got all of our files set up already. We've got this sketch called Infinite Squares. We've got everything set up, and all we need is the P5.js library, which is linked in, and it's under this folder, libraries. And we've got the sketch.js file right here. So let's actually begin and actually start doing. So right now, let's just run the sketch. So we're just going to click this little button here. Let me just make it a little bit bigger before we continue. Okay, so we're going to click play. And as you can see, we're going to get nothing. Yeah, we get absolutely nothing. So what we're going to do is, the first thing we're going to do is we're going to create a canvas. And what a canvas does is effectively, we're just saying, how far the sketch can go. And what I'm going to do is I'm going to use inner width and inner height. Now these two numbers will be the width and height of the actual browser window, which will be incredibly useful. Okay, let's do that. Next, what we're going to do is we're going to go into draw, and we're just going to do, just to check to make sure it's working, we're going to do background 0. And what this will do is it should make the canvas black. So if we just to check it, make sure it's working, we can do 125, 23, 100, and it should be the RGB value of that. So let's just check. Yep, it is working absolutely fine. So just for now, we're just going to leave it at 255. And the background will be refreshed every couple of seconds. So the first thing to do actually is to just, get a rectangle displayed into the center of the screen. So what we're going to do is, let's just do 0. Well, so we're going to do inner width divided by 2. Then we're going to do inner height divided by 2. And we'll do, let's just make it fairly big. Okay. And what it should do now, yeah, so now we got a center, we got the rectangle on the screen. Now, as you can see, it's not actually perfectly center, and there is a way to do that in P5.js. All you need to do is go to setup, and we're going to type in rect mode. I think it's rect mode. Yep. Center. I think it's spelled like that. And what it should do, yeah, so as you can see now, it's actually in the center of the screen. So effectively, when I'm drawing this, it's actually doing it in the center of the square rather than the side or the top left that P5.js usually defaults to. So now we got this, which doesn't. Oh, hang on a minute, that was the wrong window. So as you can see, we've literally, the only thing we've got is this, and that's not very, very interesting. But what we can do is that, so the way the recursion illusion actually works in this case is that what we really need to do is actually tie the rectangle to an actual library, not a library, but a class to be precise. So what we're actually going to do in this tutorial is actually build a class for this rectangle, so we can have multiple rectangles at the same time. So what we're going to do is we're just going to go into here, and we're just going to create a new class. We're going to call it rectangles, and we're going to just do that. And what we need is, we need a constructor for this class. So what I'm going to do is, I'm just going to create that, and we're just going to keep it empty for now. And this will contain important stuff later on. We're also going to need an update, and I'll go over this in a second. And we also need a show. And a show will effectively, do everything. So what we're going to do is, we're just going to say console.log rectangle is now showing. Yeah, we'll just do that. And then what we're going to do is we are going to do a push, which will, so we'll do push pop. And what we're going to do is we're going to do push pop, and we're going to do translate width divided by 2. Oh no, inner width divided by 2. Yes, that was my bad. Inner width divided by 2, and inner height divided by 2. Now you might be asking, why are we doing the translate in this function instead of just, identifying the coordinates here? Well, it's just to make the code a little bit cleaner, and also if we put like any extra objects, it will be in the same place as the rectangle. So instead of writing, this in the rect, we could literally just type in rect 0, 0, 10, 10. And we can literally do that. And let's just put some semicolons. I'm really bad with semicolons. I really need to fix that with myself. But now we got this. Now what we can do is we can actually we can effectively start pushing multiple rectangles at the same time. And what we're going to do is, to allow this, we're going to create an array. We're going to call it, actually no. So let's actually rename this to rectangle, so it's a little bit easier. And we're going to call this rectangles, and we're going to equal it to an empty array. And then what we're going to do is hold on, let me just think. Okay, I know what we're going to do. Okay, so what we're going to do is, I know this is a little bit lazy, but what we're going to do is we're just going to create an increment value up here. And what we're going to do in draw is we're going to do we'll do it after, we can do it before background. There's nothing stopping us from doing that. So what we're going to do is we're going to do if increment is above 10, we'll do rectangles dot push new rectangle. And what this will do is it will push this object into this array. And we'll do that. So new rectangle, and I think we need the parentheses for that. And what we're going to do is we're going to make increment equals 0. And as long as increment is always increasing, in this case, so increment value generates after 10 frames. So just as a little note, P5.js, the draw function will refresh at whatever the frame rate of the sketch is. Now, in this case, the frame rate is 60 frames per second. So effectively, 6 times a second, there'll be a new rectangle pushed to the screen. Although we won't be able to visually see it because there won't be anything, important. It will just be static. But at least we'll know that the length is going up. So what we're going to do is, so we got that. So we got new rectangles. And what we actually need to do is we need to actually display it, because right now, if we just run this as it is, let's go here. We just absolutely nothing at all. So what we're gonna do is we're gonna do for we're gonna let I equals 0. I is less than rectangles dot length. So we're gonna loop through the entire array. We do I plus plus. Do that. And then we're going to do rectangles dot, rectangle I, rectangles, sorry, I'm using the word too much. Okay, rectangles I dot show. And what this should do is, if we run it now, well, that is interesting, that hasn't happened. Okay, sorry about that. I made a couple of mistakes. So first off, I was making increment equal 10 rather than just 0, and effectively resetting the increment. So effectively, it was just not going anywhere. And also, I made the mistake of not making this a var, although I've just kept it as a let, and I've just made it equal to 0. So if you're having problems, although to be honest, we'll probably just be better off using it as a var. But for now, we're just going to use it as a let, just to make the code a little bit cleaner for now. So now we've just got this simple square, and if we click it, because I've actually added a function down here, which effectively will give us the length of the rectangles array. So if we click that, so we've got 13 squares in this. So you might be wondering, how do we actually make it move? Well, the answer to that is actually not that difficult, and that is the complete wrong screen again. I keep on doing that. Okay, so most of it is going to be done for the constructor and the update. So all we need to do is we need to make the square actually bigger. So we need to make it bigger throughout its life, or throughout its, effectively getting bigger and bigger and bigger. So what we're going to do is we're going to do this dot size equals 5, and we're going to do this dot. Actually, no, we're not going to do that yet. We're just going to do this dot size equals 5, or we could make it actually equal 0. There's nothing stopping us. Yeah, we could actually. Let's make it 5 now. And next, what we're going to do is we're going to make this dot size plus plus. And effectively what we're doing is we're making this variable bigger every frame. And then finally, all we need to do is we just need to make a reference to this dot size in here. And now, if we should play it, it should get bigger, hopefully. Oh, okay, no, I completely forgot something. Okay, so not only we need to update show, we actually need to do rectangles i.update. So the actual thing will actually update. So now, yeah. So you can see now, we've got this quite trippy illusion, but as you can see, it's actually working and it is expanding and it looks fairly cool. However, there is a couple of problems with this. So effectively, this will continue to make effectively squares forever. And this is actually quite hard to look at. But effectively, this will keep squares to look at, so effectively the squares will keep on generating infinitely, even if they're out of the screen. So all we need to do is we need to figure out a way to remove them. And the easiest way to do that is to actually create a new function. So what we're going to do is we're going to go back to class, and we're going to create a new function called gone. And with gone, what we're going to do is we're going to make we're going to make a condition. And what we're going to do is we're going to make a condition. What we want it to do is effectively when this dot size reaches a certain size, we need it to just, go away, just disappear. And the best way to do that is to actually just use the width, or the inner width to be exact. So what we can literally do is we can type in return this dot size is more than inner width. And effectively, this will tell us if the square needs to be, spliced from the array. And that's what we're actually going to do in here. So what we're going to do is we're going to go back to drop. So we're going to go back to here. And I'm going to type in if rectangles. Oh, wait, no. Yeah, no, it is rectangles. I keep on forgetting. Rectangles I dot gone. So effectively, this will check if the rectangle needs to go. And we're going to just type in rectangles I dot splice. Oh no, we don't need to do that. So we're going to do dot splice I and 1. And what this does is effectively we just remove the element from the array. And just to make sure it's working, what we're actually going to do is we're just going to make this a much lower value. So let's just say 200. And what this should do is when it gets to 200, yeah. So as you can see, it's actually like it's kind of causing a bit of a inverse effect, but it is working. So effectively, when this dot size equals 200, it will just stop. It will just start removing it. But as you can see, it doesn't look right. But what we're going to do is we're just going to make it inner width, and it should work, hopefully. Yeah, now it's working. So let's just make it. Let's not make it yellow because I actually really hate that color. And let's just make it white for now. So now we got this. The next part is to actually make it rotate and overlap with itself. And the way we're going to do that is actually through rotation. So obviously, so what we're going to do is we're going to do this dot rotation. I'm going to make it equal to 0. And we're going to do the exact same thing in here. So we're going to do this dot rotation plus plus. And what we're going to do is we're literally just going to add rotate to this translate. So let's just do it. Yeah, this code isn't very clean, but that's not really the problem for now. So rotate, and then we'll do this dot rotation. Okay, and now, oh god, that looks really bad, and I should probably fix that. Oh god, that is okay. I think I might have a rough idea of what it is. I think it's to do with what do you call it? Okay, I know what it is. Okay, so we need to go to, so right now, this weird looking sketch thing, the reason why it's doing this is because it's using the wrong angle mode. It's doing it in radians, which is, a much more what's the word? It changes a lot. So what we're going to do is we're actually going to make it just change the degrees. So we can do it with that. So angel mode degrees, and now, yeah. So now we get a nice little sketch, and it looks really, really nice. And it's actually quite slow, and it's actually quite nice. Yeah. And also, if you want the same illusion that I did earlier with the where effectively the lines are overlapping, all we need to do is disable the color in the inside and just make it the outline. So all we can do, just for the sake of demonstrations, I can do no fill. Yep, we'll do that. And now, yeah, and now it should start overlapping. Yeah, so now we've got where I started with. And actually, to be honest, I actually prefer the other one, but this is actually quite nice. Yeah, it's actually a bit slower and it's a bit nicer. And yeah, so effectively, this should just keep generating and you won't have any memory problems because after a while, the actual squares will start getting removed. So effectively, it will just keep generating forever. And if you wanted to extend the sketch, you could add maybe an ability to, change the colors for each square. And you can make the color change, for every new square, or you could make it change over a lifetime. So you could make it like a lifespan sort of thing. So for the size, you can make the color change. Actually, we could just demonstrate that right now. Look, let's just do fill 00 this dot size. And what it will do, I mean, it will look really bad. Yeah, but as you can see, it's actually getting more and more blue as we're doing that. So yeah, that's cool. Yeah. Anyways, that's kind of really it. And like I said, you could apply this to so many different things. You could apply it to, a circle. You could apply it to triangles. You could apply it to anything. And also, you don't have to rotate it. It's just something that I've done. But as you can see, this recursion illusion is actually, kind of nice. It's kind of cool. And I like it, expanding out the center. It kind of looks like an optical illusion. Anyways, it's been Effects. No, it's been Oliver. And if you've got any questions, just leave in the YouTube comments. As like with the previous video, this code will be available on GitHub, and I will see you later.